Yeah, it's awesome to be here. Thank you for having me. Come up from Melbourne today to speak. I'm not, please don't hold the Melbourne thing against me. I'm actually from Perth originally. I don't get into the whole Melbourne City thing. I'm neutral. I'm like Switzerland. Cool, so yeah, I actually gave this talk a couple of weeks ago at Serverless Conf in New York. And it was originally titled The Story of a Serverless Startup. And when I submitted it, I was told that it was not catchy enough. The title wasn't catchy enough. It wasn't cool. It wasn't going to draw people in. So they said, get a talk that's going to draw people in. So I did some research online. And I found apparently the way to do this. Oh, what's happening? Is clickbait. You see that? This is terrible. Sorry, it's a PDF. So yeah, I went back and I retitled the talk. I'm not sure what's happening yet. You can't see the whole screen.
Could you please stand in the middle? Yeah.
Sorry.
Stand in the middle, yeah.
They need to stand here.
Yeah. Thank you.
Anyway, so this talk is called 10 Tips for Running a Serverless Business. Number 6 will blow your mind. And, it turns out that, oh, there we go. That's better. Oh, perfect. Ruined my joke. So, this is a little bit, I guess, uncomfortable because I actually only have 9 tips. But it did beat my other clickbait titles, which are this company destroyed all its servers and people are freaking out. And this business got free cloud hosting with this one weird trick. Cool. So, there's my stand-up comedy. It's over. So a little bit about me. Oh, this is ruining all my jokes. Wow. Okay, I'll leave that one up for a while. I'm used to presenting from PowerPoint as a PDF, so there's no animations and things. So yeah, a little bit about me. I'm Sam Kronenberg. I'm one of the founders of AWS Guru. If you haven't heard of us, we're an online learning platform and we teach people about AWS. We train engineers in all things cloud. And we've built our platform entirely on serverless technologies. In fact, we're an entirely serverless company. And to give you proof, that's a screenshot of our EC2 dashboard. Launch instance, there's nothing there. So, interesting fact about me. Terrible. So, I did not star in Back to the Future. Prior to AWS Guru, I worked for Microsoft in Seattle, and I was a developer on Windows Vista and Windows 7. In the Windows team, I worked in the core file systems group of Windows, and there my major focus was the disk defragmenter. So I actually owned defrag in Windows, and I had the honor of rewriting defrag for Windows 7 from 0 lines of code. Just delete the entire repository and start again, which was amazing. And I usually get really mixed reactions from people when I tell them that I wrote defrag. But yeah, got to redo it. So that was cool. So I guess I'm definitely a convert to serverless, right? I built Windows Server. I spent a lot of my career working on server software. So, here we go. In this talk, I'll take you through the last 2 years of our lives, building one of the world's first entirely serverless web platforms at scale, launching a serverless platform before anyone was even using the term serverless, before you could call Lambda from the web. And I think we're an interesting case study because for businesses who are looking to invest in serverless, because we've kind of been to the future and we've come back. Like, we're 2 years in, and there's not many businesses who are 2 years into running an entirely serverless business. So, we've been through that whole journey that a lot of companies are now just starting on. We've learned where the serverless technologies have given us a massive acceleration in getting to market, and where they've brought real challenges for us. So this isn't your typical tech talk on functions and deployments and pipelines. And today I'm going to tell you the story of building a serverless business and aim to give you some insights that you can use on that if you're going through that journey as well. So 2 years ago, we had this crazy idea. I still remember when my brother and Ryan and I had this phone call, and we thought, well, what if we could change the way that people learn cloud computing? And he had just put a couple of AWS courses up online on an online platform, and they were starting to get attention. And we decided, well, what if we could if we could build the place to learn cloud computing, so like a massive online community where IT professionals all come together and help each other, and we can do really affordable, great quality training. So it's been a crazy couple of years where we've taught cloud computing to 350,000 engineers. I think it's close to 400,000 now, in 140 countries, over the last 2 years. We've got offices now in Melbourne, Texas, and London. And we also started a conference, because we're insane. And we thought it would be easy. It was like April last year, we decided to rent a warehouse in Brooklyn, in New York, and run serverless conference, because no one was doing a conference on serverless, and there was a whole lot of pioneers in the industry. So we rented this crazy little warehouse, and we forgot to get air conditioning. April's hot in New York, and it was bad. But the conference was amazing. Everybody sweated through it. And it was fantastic. We've run 5 now. So we've run the original New York conference, we've run Tokyo, London, Austin, Texas, and 2 weeks ago we ran the second New York conference, which was awesome. And it's such a cool conference because all of the cloud vendors come, so Amazon, IBM, Microsoft, and Google all sponsor and come, and they actually bring the product teams who build Azure Functions, Lambda, OpenWhisk, and Google Cloud Functions. So it's the actual engineers who build it, and they're there and you can talk to them. And they talk to each other, which is always really interesting too. So there we were. It was mid-May 2015. I actually just the other day found a video that 2 weeks into building the platform where I took a video of it and to show Ryan what I was doing. And we wanted to launch this startup. We wanted to kind of rocket to market, but we had to find a way to escape the pull of our normal lives. So we had mortgages, financial commitments, we've got kids, and so we needed to get something to market quickly to see if we had a product that people actually wanted. Like, do people want to buy this? Do they want this training? So we needed to start earning enough income quickly to focus on this full time and get going. The problem was how to get off the ground. So I'd love to tell you that there was this amazing grand vision to go serverless, because that would make a really cool story. But it wasn't. It was, I think like a lot of innovation, it was born of constraint. So I had 4 weeks of leave in my job saved up at the time. And my wife, who was incredibly supportive, encouraged me to use it to build the school. We actually had a family holiday plan that we'd been saving up for a few years, and we cancelled it and we postponed it, and we got the 4 kids on a plane and we went down to Tasmania, and I locked myself in a bedroom for 4 weeks to build this learning management system. So you can imagine how popular I was with the family. I'm still paying down that debt. So to be successful, this school, it had to have these features to be able to just get to market. It had to have a video player, a quiz engine, a store, a checkout. It had to scale effortlessly without a lot of operational support because I didn't have an ops team. It was just me and Ryan at the time. And I think I was very daunted by the scale of trying to build this all in 4 weeks using traditional software architectures. You know, I was a software dev, I built a lot of systems. And so my first attempt was off-the-shelf software. I actually spent 2 days configuring Moodle and trying to skin it. Put CSS layer over Moodle, and it was an absolute disaster. It was terrible, and I started freaking out that, you know, had I wasted my time? Why was I doing this? So I went back to the drawing board and I started thinking, how can I outsource as much of this as possible? Like, what is already a solved problem in the market, and what accelerators are available to me? And then I remembered Auth0, which is authentication as a service. And in previous projects, I had spent weeks alone just implementing authentication, creating sign-up screens, a login screen, a forgotten password wizard, social media sign-on, there's all of that as well. It's a big beast to do from scratch. But with Auth0, you create an account, drop a few lines of JavaScript code into your web app, and it's all done for you. Even the login box they render, like I didn't have to build the login box, which is amazing. And I also remembered that I'd been playing with a service called Firebase, which was at the time, I mean it still is, it's a NoSQL database done a little bit differently. It was built for the web. So Firebase's database can connect directly to the web browser, meaning that when your site loads in a user's web browser, it talks directly to Firebase through the web, and there's no intermediate web server required. So now I was able to put a whole bunch of course information into Firebase, the Firebase database. So we had some courses that we wanted to deliver: titles, descriptions, lessons, quiz data, all that stuff. And our site could access it directly from the user's browser with an AngularJS code. And I didn't need to build a middle tier layer here to act as a proxy between the front end and the database. And this saves a massive amount of time. When you've only got 4 weeks, that's really crucial. So it was less time spent on plumbing and infrastructure and more time spent on building features for our customers. But there's some things you can't do in the front end, right? Like actions that load private or sensitive data, calls to other services like Stripe or PayPal, you can't call them from users' front ends, if they need secret keys. So this meant that I needed a web server, which I found really annoying because I only needed it to do just a very small handful of things now, but I still had to deal with all the scaling, infrastructure, and monitoring that comes along with running web servers. And then I remembered WebTask. So WebTask was a service that you could upload a single JavaScript function to, and it would expose that function at a HTTP endpoint that you could invoke to call the function. It was originally built as a way of running small webhooks without having to stand up a whole server. This was kind of Lambda before Lambda came out. And it was actually built by the Auth0 guys as a separate product. And so I realized that for those few protected actions that we did need to do in the cloud, in the back end, like authorizing payments, we could do them on WebTask. So I would write a little bit of JavaScript code. I would upload it to WebTask, that's me, go to WebTask. It would give me a HTTP address back. Our front-end app would call that HTTP address to say authorize a credit card payment. WebTask would run that function. It would call out to Stripe, do the authorization. If it succeeded, it would write to Firebase and say, yep, Sam or this user now has access to that particular course, which then would synchronize automatically through WebSockets straight back to the user, and they'll be able to access that course. So the whole thing worked in a serverless manner. So then after a little while, API Gateway came out, so you could now invoke Lambda from the web, and we moved to Lambda to run these functions instead of WebTask. So in a model like this, we had this truly standalone front-end app, if you think about it. The HTML, JavaScript, and CSS can be served entirely by a CDN. It doesn't need to be run on a web server at all because there's no data in it. All the data is behind APIs. So we could literally plonk it on a CDN like CloudFront to distribute it, so it was lightning fast to load. And if you think about it, we had a first rudimentary serverless architecture. And the entire thing was served by web services that managed provisioning, monitoring, and scaling for us, and provided us with great SLAs. And everything was low cost, and the most important thing is that the bills scaled with usage. Because you never pay for idle with any of this stuff. You only pay when a customer comes to do something. So that was cool. And that architecture was really good for request response scenarios. Someone does something on the site, invokes a short action, returns a response. But what if you want to kick off like a longer running process, something that can take minutes or hours and has multiple stages? Well, it turns out the serverless architectures are really good for that too. So you can build these robust event-driven pipelines. And I think Pete from our company has talked here before about this, so I won't bang on about it too much. But this is a very rudimentary example of our video transcoding pipeline. One of our instructors comes to our website. They've got a new video they've recorded to teach someone about something, like a new lesson on Lambda or something. It uploads straight to an S3 bucket from their browser, which we hang a Lambda function off. That Lambda function, its sole job is just to schedule a job in Elastic Transcoder to transcode that very high quality, might be a 4K video, down to 1080p, 720p, 480p, HLS, adaptive streaming, a whole bunch of different ways in which our customers want to consume that video. So they all get pushed into a destination S3 bucket. We hang a Lambda off that. That Lambda says, that fires when, oh great, there's a 480p video, a 480p transcoded version of this video now available. I'm going to store that in the database and tell the user that it's available. And it then get published out to the site. So all of that's done in an event-driven manner, and only a very, very small amount of custom code needed from us to glue this whole very powerful pipeline. So that was it. We launched the site in September 2015, and we had liftoff, and a customer customers really started coming quickly, and people were enjoying it, and the site was delivering on its core functionality, and we didn't have to worry about monitoring or ops, operating infrastructure, and it meant we could keep the team really small early on and build some funds in the business, because we were not a funded startup. We didn't take funding for 2.5 years, 2 years. So we were riding the serverless rocket. We escaped the real world finally. We could work on this, and it gave us serverless gave us a whole bunch of accelerators to move really quickly. But then we started realizing that things were a little bit different in this new model. So it wasn't exactly like previous companies I'd worked in, and serverless brought some new opportunities, which was awesome, but it also brought some challenges, and we had to adapt. So I promised you 10 tips for running a serverless business, and here they are. So number 1, no ops? No. There's still ops. So there was a myth early on in the serverless movement, if you want to call it that serverless meant no ops. And it doesn't, to be very clear. But it does shift the responsibility for ops. It changes the makeup of your engineering team. So in a world where third-party services now do so much of the heavy lifting for you, you have to consider these services, like AWS, as part of your ops team. You might have heard Charity Majors talk about this before. There's some great videos online if you go and look up Charity Majors. She says it way better than I do. But if you use AWS like us, then Amazon run the servers and Amazon are part of your ops team. Auth0 are part of your ops team. Firebase are part of your ops team. You need to have a good understanding of your dependency on third parties and have some clearly understood and documented lines of escalation when something goes wrong. Like if something goes wrong in the middle of the night, whoever's on duty needs to understand how to escalate that to the right company, who to work with, and what the process is for resolving it. Like literally, we had a massive deployment scheduled for yesterday. It was something the team's been working on for 4 months. And Travis CI went down, and that's our deployment service. They went down 5 hours. And then we spent the day dealing with this huge backlog. It was 1 hour, let alone actually run. That's the trade-off you make. We get the power of Travis CI, but when something goes wrong, we have to know how to work with them to get it resolved. Don't look for serverless developers. Hiring developers for a serverless team is trickier than it would seem. First, there are no serverless developers with 5 years experience. They don't exist. So we learned very quickly not to advertise for serverless for serverless developers. There are just so few out there, even for people with any serverless experience, there are so few out there that you really limit your options. And only now are we actually starting to hire people who have even used, say, function as a service before working with us. And even then, it's like on some small hobby project. So when you're hiring, you should think about what you're looking for. Your developers are now more responsible than ever for ensuring the smooth operation of the system, right? So the automating deployment pipelines, anticipating like the many ways in which this system can fail, implementing robust monitoring systems. What if you get a logjam in your Kinesis streams? How are you going to deal with that? Failovers, managing databases. So it's no longer good enough to hire that ace developer who obsesses over the elegant code, that beautiful, efficient algorithm, you know, that really geeks out on like hardcore ComSci problems with data structures. You want the developer who cares about alerts, logging, right? How are you going to like correlate events across the distributed system and find out where something went wrong 3 hops back? How are you going to deal with rolling back a bad deployment? So you want developers who obsess over the smooth running of their code in production. So hire for accountability is my advice. The other thing, encourage and reassure candidates. So the other thing that happened, when we first started hiring, we thought that people would flock to work for us because the technology that we were working on was so new and that was so cutting edge and fun. But we learned something really quickly. Our job ads would focus on like, hey, we use Lambda and DynamoDB and Kinesis and CloudFormation and all this stuff. And we talk about being an entirely serverless business, cloud native, blah, 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 blah. And it scared a lot of people off. It scared most people off, right? Because they would read it and they would say, well, I don't have any experience with this stuff. I'm not going to get through the interview process. Someone else will get it in front of me. How will I differentiate myself? So it was quite shocking. Like, there just wasn't a lot of response to our ads. So we changed it up and we made our job ads focus on like, hey, we use the latest, coolest cloud technology, and you're going to learn a lot working here. It's going to be a lot of fun. We're not looking for serverless experts. We're looking for smart devs who care about building quality systems with robust engineering practices. We're a team, and I think it's important to tell people that you're a team that value learning and constant improvement, and we're going to support you all the way. So we found that if we could excite candidates about the work, but then encourage them to apply and reassure them that we'll be there to help them learn and upskill, that was much more effective. Use the community. The community around serverless is amazing. There's a lot of great people out there with interesting articles, people you can talk to, because the challenges that you'll come up against are faced by everyone else. So like, we learned about Algolia. We built a lot of our website on Algolia, which is a distributed, it's kind of like a CDN for search. It's an amazing search product that distributes your indexes around the world. It's really, really nice. And I heard about that from Joe Emerson at the first Serverless Conf. He gave a talk on it. And it's transformed the performance of our website. We've used technologies that have come out of the community, like around the serverless framework, for example, and our developers contribute back to the serverless framework. And so here's some awesome resources that I would recommend. So it looks like a shameless plug, but I promise you it's not. Read.acloud.guru is our blog, but this isn't a blog that we write. Like, we don't write articles on here. It's a community-sourced journal. So everyone else writes blogs and we curate them and bring them in here. So there's a lot of really cool stories and advice from people working with serverless technologies and cloud computing in general. I also suggest reading the Newstack, which is a great blog, and serverlesszone.com, great online publications. There's also a serverless Slack channel that a lot of people are part of. And Twitter is an awesome source of discussion. I would recommend following these people. So people like Jared Short, Ben Kehoe from iRobot, Mark Nunakovic from Trend Micro, Lynn Langett is amazing, does a lot of Google, big data stuff with Google, BigQuery. Pete Sparsky, who works for us and runs the Serverless conference. Also, they're all great teachers in the community. So you expect to pioneer. So serverless is a young ecosystem. It has matured a lot in the last couple of years, but if you invest in serverless, don't be fooled. Your team will spend time developing patterns and modifying frameworks. They'll be investing in pioneering in serverless technologies. It's not a drop-in Rails and Go solution at this point. There are problems yet to be solved. There's a lot of smart people working on it, but don't expect to have all the problems solved for you, drag and drop, beautiful like Visual Studio development. It's not like that. We've spent time rolling our own build systems and then throwing them out when Serverless Framework came out. We've spent time building plugins for Serverless Framework, and then we threw them out when those features became part of the native framework. So we've thrown a lot of code out. But teams that can overcome working with a young ecosystem like that will really excel. So you'll lose some time building that tooling that doesn't exist, but overall, your team are going to be able to focus on your product more and spend less time on traditional operation tasks. And I think more importantly, you'll have a more engaged team, because it's way more fun building tools and contributing to interesting frameworks and pushing the game forward than it is managing servers. I just saw Adam up back there. Is that you, Adam? Or am I? Sorry? Oh, you look like Adam. Oh, sorry. Ignore me. I won't shout out to Adam. Sorry. I need glasses. That was my big reveal. Number 6, to blow your mind. It's okay to build a serverless monolith. Seriously, it's okay. You can do that. And that's what we did, because if you think about our original architecture that I explained before, that very first architecture, it was serverless, but it was a monolith. It's one database, everything coupled to it, and that's fine. Like, it got us to market. There's a bunch of functions, but they're all writing to the same database. Everything's coupled together. If you change the database schema, you're going to break all the functions at the same time. It's still a monolith. But this was great to get to market, but it did present challenges. The same kind of challenges that all monoliths present. So with the front end coupled directly into the database, how could we add a mobile app, for example? There's no versioned consistent API. With Firebase existing outside of, say, the AWS CloudFormation sphere, how would we provision new environments automatically, or programmatically? How would we scale from just a few developers to 10 to 20 to 50 without everybody stepping over each other with a single code base and a single database? So we decided to move to a microservices architecture. So in the microservices architecture, each distinct business domain is represented by a separate microservice. And each microservice is responsible for its own view of the world, like its own database, its own API. And this allowed us to achieve a lot of acceleration with highly focused teams, because you have a team that's focused on one particular service. That's the learning record service or the authentication service, and that's what they do, that's what they know. And it allows services with different, say, scaling calculations. You can allocate different DynamoDB read-write throughput scenarios. So this is an example of how our microservices work. So this is, say, the learning record service. So if someone comes to their own website and they complete a course, it'll call out to API Gateway. If you run a custom authorizer to make sure that they are who they say they are, it will then invoke the Lambda. And that Lambda, all it's responsible for doing is validating that they have completed the course and then saving to Dynamo they've completed the course. And early on, we had our Lambda function doing lots of different things. So one Lambda function would call out here, write to a database, call out to another service, do this, do that. And I learned from Paul Johnson a couple of years ago at Serverless Conf, he said, your Lambda function should write 0 or 1 times. Each Lambda function should only write 0 or 1. Like, there should only be one side effect, because if there's 2 or 3, if it fails halfway through, you don't know what's happened, right? There's no way of guaranteeing what's happened in the system. So we'll write that record to Dynamo, and then Dynamo, we hang off DynamoDB streams other Lambda functions, which then go and update other parts of the system, because we can do that. Once it's written to Dynamo, we know it's safe. It's a single source of truth. We know that it's true. Bob has completed the CSA course. Great, what do we want to do with that information? Well, let's save it out to Firebase. Bob has completed the CSA course. Let's save it to Algolia so we can search against it. Bob has completed the CSA course. So that state gets updated everywhere. And if you think about what we've done here, before we did this, the source of truth was Firebase. But now the source of truth is Dynamo. And it's behind a consistent versioned API, but without having to decouple the front-end web browser code from Firebase. So Firebase, in fact, like, we may never decouple it. Firebase is effectively acting as a read store, like a materialized view. The UI just reads from it. It doesn't know how it gets populated, it doesn't care. So this allowed us to migrate towards a new architecture in stages and not a big bang release. Like, ripping Firebase out of the whole architecture in one release would have been insane and probably impossible. So we could just stage it. And if you think about this, we've migrated from a monolithic architecture to microservices without even having to think about infrastructure. Like, we haven't thought about server provisioning, web farms, load balancers, any of the stuff you normally would have to do to change your architecture. We change our architecture by changing a single YAML file in a serverless framework repository. In our repository, it's like YAML file. Okay, now we have this API calls this instead of this calling this. And I think that's really powerful. Like, CloudFormation just seamlessly upgrades the whole system for us and keeps it all running. So serverless, to me, I think one thing that became really apparent over the last couple of years is that going serverless amplifies that need for good development practices. So, the kind of things that dev teams have been striving for over the past 10 years, but often fallen short on, when as soon as timelines or budgets get tight, it all gets thrown out the window. A lot of that stuff is not really optional in the serverless world. So let's have a look at this through a couple of lenses. So the first is a need for automation, say automated deployments. Automation is not optional in the serverless world. So they're distributed systems. Think about it. Serverless systems are distributed systems with hundreds of interconnected moving parts. So once you scale past just a few functions, you can't deploy these systems manually. You just can't. It's too complicated. There's too many pieces to upgrade and connect together. And then think about it, you've got like multiple environments, one for each developer. You've got staging, UAT, prod. You can't keep all of that going without automation. And this is where frameworks like Serverless Framework are really useful, and they've contributed massively to the ecosystem. Because we all struggled too hard for too long to build our own deployment systems in the early days. And testing. The need for unit testing is like the second lens here. Like testing with high code. You can't run a serverless system in a local dev environment. Really. Cloud native. You need the cloud. You can never fully emulate the operating environment of the cloud for development purposes. So you might be able to emulate a function running locally on Node.js, for example, but then your function needs to write the file to S3. You can't emulate S3, right? Or writes to an SNS topic. And then those things trigger off another Lambda function, which is triggered off in the cloud, not on your local dev environment. So it's not feasible to emulate the whole cloud environment locally, at least not on AWS. Caveat, I know Azure are trying really hard to do this with Azure Stack, but I don't know enough about it, so I won't comment. So we did have a lot of unit tests early on, but it was all about getting to market and see if we could make this thing fly. So we didn't have a lot of unit tests. So a lot of our testing was manual on local development environments, and then came what I call the cycle of despair. So you write your code, your function, and then you get in the CLI and you upload it to AWS, and then you run your little web server locally, but it's pointed at the cloud functions. And then it fails, of course, because no one ever writes good code the first time. And then you're like, why did it fail? So then you open CloudWatch, and you scroll through and you look at the exception, and then you realize why you're an idiot. And then you go back to the start and you change the code, and the whole thing starts again. And it's an incredibly painful way of building software. It's an absolute nightmare. So for a while, we dabbled with a few ways to kind of emulate the AWS environment locally, like Serverless Offline was a plugin, Serverless Simulate, now there's SAM Local, but they're all band-aid solutions in my view. You cannot emulate the entire cloud on your dev machine, so don't try. The way to solve this permanently is with a solid unit testing strategy with high code coverage. So if you can isolate each function in your serverless system and test it robustly with unit tests, like you can be confident in the operation of each part of the system in isolation. And you can run all your tests locally on the dev machine as you write them. So your test should be the first user of your system. You should write to your tests, TDD style development. That's the way we go over this, and this is the way our entire team works now. It's a much better way of building. Number 9, last one. So the last thing I recommend thinking about is that when you're going serverless, you're building against managed services. And managed services are moving targets. For example, Firebase decided to get bought by Google, which was great for them, but they made their old version obsolete. And they told us on March 31st, we're going to shut it down, your website's going to stop working. So you better go and do some dev work to work with our new version. Lambda deprecated support for Node 0.10. And when we started, everything was written in Node 0.10, and we still have a fair few old functions hanging around that were just working. We didn't need to change them. And we have deadlines. If we didn't hit those deadlines, our website was going to stop working. So, if you're using third parties, you're going to get the benefit of them managing everything, entire parts of your system for you. You're going to get the benefit of moving the game forward. But the flip side is that they'll pull the rug out from under you regularly, often. And you need to be accepting of this and always ready to move forward with them. And it also underscores the importance of doing your homework on a company before you let them become a core part of the system. You have to know who you're relying on. So that's it. We went from nothing to a serverless monolith to serverless microservices. We worked out how to build local dev environments or without local dev environments. We worked out how to attract good talent, run an ops team that spans a whole bunch of companies. Which leads me to tip 10. Which is have fun. It's a really exciting time in our industry. We've got incredible power at our fingertips when you look at it, and it's up to us to build the apps of the future. So I encourage everyone to get involved and get your hands dirty with serverless if you haven't already. I think all in all, building an entirely serverless app and business has had a lot of advantages for us. Like, it's presented some interesting engineering challenges. It's not all rainbows and unicorns. It's really, really not. But I firmly believed it enabled us to get to market. We simply would not have a business without serverless technologies. And then we could move at a pace that we couldn't have otherwise. Thank you very much. Any questions?
Just to your last point, the rug being pulled out of you. I mean, as a startup just getting to market, you kind of cobble whatever you can together to get the features there. But at what point do you feel, for instance, authentication, that's kind of make or break, right? If Auth0 changed their API, did some minor change, surely the impact of your organization is huge. So at what point do you think, I'm going to unbolt them?
So at what point do you decide to move away from a service or realize you're too dependent?
Or deprecate them because that changes too.
I mean, Auth0 is an interesting one because they handle our logins, and if they go away, none of our users can log in. It's a trade-off, and you have to have a good relationship. Like, we have a very good relationship with our account managers inside Auth0, and we did a lot of homework on their. I wouldn't say we did it initially, but as we started getting bigger, we did a lot of homework on their strategy. Like, they have a company that is an escrow company that actually holds all of their code, and they have an agreement with them. The agreement basically says that even if Auth0 go bankrupt, the escrow company will stand up these services and run them. They're an entirely separate third-party company that will run Auth0 services for a certain amount of time. They will also provide all of the code over to all of their affected customers. So there is a strategy there, and we're pretty happy with that. If we become a billion-dollar company, hopefully, one day.
Next week.
If we get to that size, I'm sure there will be a different level of scrutiny, and we may be looking at bringing that stuff in-house. And it is a strategy with Auth0 to be able to migrate away from them to a. You can basically have Auth0 run, say, like your own custom database and write to your own database, which you manage, but it's still Auth0 writing and reading from it. So there are some kind of hybrid strategies as well. But yeah, it's a really good question, and there's no answer. It's just like investigate, be level-headed, be thoughtful about it, and make the right decisions for the risk profile.
Yeah.
So,
Oh, yep. But you had your hand up before, so I'll sorry.
I have a question regarding your point number 8, testing. You brought up that good test registry is crucial and good code coverage. Do you have any learnings around the tooling? Which tools made it hard for you, for example, to test your Node.js function with callbacks and make it easier? Also, in conjunction with your CI/CD platform.
I mean, we run everything through our CI platform. Like, all the tests are run on check-in. Learning, it's all just done through the CI tool. You know, and the devs run it locally. I think we've been through 3 or 4 testing frameworks now. We use Jest at the moment. I can't even remember what the last one was. We started with. Oh God, there's been so many. It's all the same kind of stuff. I think it just generally in terms of monitoring, we try to use AWS native tooling as much as possible. So CloudWatch alerts, CloudWatch dashboards. X-Ray has been an amazing addition. So yeah, I don't know if that answers your question.
Two more.
What sort of cost savings have you realised over the years since you developed without service?
It's very hard to say because we've never run it with servers. All I can say is that pretty much the only thing we spend money on in AWS is bandwidth, serving videos out. I think until about 6 months ago, we'd never paid for Lambda. So we'd never paid for compute ever. I think we pay about $1.50 a month now for Lambda, something like that. It's pretty awesome. It's nearly entirely bandwidth out and a little bit of Redshift, because Redshift is not cheap. But yeah, so it's very hard to say, but I know the kind of scale we've been doing at previous companies I worked for. We would have been seeing hosting bills in the many tens of thousands a month, and our hosting bills are nowhere near that.
So how do you build and deploy your serverless solution to Lambdas?
So we use Serverless framework.
Yeah.
to
You use
describe the system.
pipeline or Jenkins or
We use Travis CI.
Travis CI.
I don't want to say too much publicly, but I wouldn't recommend it. We had a very bad 48 hours with Travis CI, and it's been about a year. So yeah, there's good CI services, but yeah. Probably get sued.
Excellent. Thank you, everyone. Sam, thank you very much. So just everyone, thank you for coming. Next month, who's here is going to reInvent? Is anyone here going to reInvent? No? In Vegas? No? Sam? Yeah, so cool. So Sam is going. So next month we're actually running in 2 Park Street. Who here has been to the AWS offices in Sydney? Yes, you know where it is? So if you come here and you kind of text us and say, where is everyone? I'll just say, oh my God. I'm telling you now, we're not going to be here next month. We'll be at 2 Park Street, which is the AWS offices. They're in around Town Hall Station, so go just over there across the road. And what we're going to do is we're going to do a panel review of people who are at reInvent and give us some insights into what it is. So come along. Thank you for coming tonight. See you next month. Take it easy. Be good. Thank you. Thanks everyone. Bye.